Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and nature topics. If you find these videos helpful, please consider supporting me on PayPal, Patreon or Buy Me a Coffee. Links in the description box below. Today we're going to cover Strength of Materials in 6. The topic of this tutorial is question 6 of the DP exam that was written on the 25th of May 2023. The formulas used are included in the video. The question is also posted in the description box below. We have been asked to issue a cautionary note. Some of the formulas used in these videos, which are taken from DP exams and past papers, do not appear in most textbooks or the formula sheet attached to your exam. You will need to know them in order to do some of the sums. They appear in the beginning and end screens. Let's get straight into it. Question 6 states, okay, let's get straight into it. First things first as we read the question. A steel reinforced beam is simply supported at its ends. The T-beam has a flange that is 500 millimeters wide, 80 millimeters thick. The web is 200 millimeters wide and the effective depth of the reinforcement is 600 millimeters from the top of the beam. The area of reinforcement is 200 millimeters squared. The maximum allowable stresses for the steel and concrete are 140 megapascals and 5.2 megapascals respectively. Assume the modular ratio is 15. Calculate the following. 6.1. The position of the neutral axis by taking moments about the neutral axis. Number 6.2. The maximum bending moment that the beam can handle. Number 3, the actual stress in the concrete. Number 4, the actual moment of resistance in the concrete. And number 5, the actual moment of resistance of the steel. So, first things first is we're going to do 6.1. So, we've got to find the value for n. 6.1. So, M A S M8 to the power steel, area of steel, times D minus N. Okay, equals A1 Y1 plus A2 Y2. So what they want us to find is the position of the neutral axis by taking moments about the neutral axis. So that is when we use this formula here. We are looking for n. So what we have here is 15, because that's the modular. The modular ratio is 15. So M equals 15. The area of steel reinforcement is 200. 200 times 10 to the minus 6. Okay, now we've found the module, which is M. We found the area of steel reinforcement, which is 200. So now, times 200 times 10 to the minus 6, we have D. D is 0,6. That's the depth of reinforcement. Depth Re-N. Depth of reinforcement is 0,6. So this is 0,6 minus N. And this equals, I'm going to move this down here. All because it's going to be quite long. So A1 is 0,5 times 0,8. 0,08 plus times n minus 0,04 plus 0,2 times 0,5 times n minus 0,08 squared. Okay, what we have here is the 0.08 is the thickness of the flange. So thickness is 0,08, 0,5 is the width, 0,5, and also the web is 0,2. These are all in meters. And the 80 mil is thickness. And these two, this here and this here, this one here, this particular one, comes from your hot roll tables. Because this is not mentioned in the question, so therefore it comes from your hot roll tables. Now, what we're going to do is work out n. So, we multiply all these in, which we can do, but we will end up basically with n squared plus 270n minus 27600 equals 0. So what we're going to do to solve this makes sense, because wherever we have n squared, there's your n squared, there's your n, and there's another n here. Every number, all the numbers add up to this, there's an n and there's an n squared. So they all add up to these eventually. They will get there, but you will do each one, so you'll multiply each one through, and you will get them separately. This is so this is outside, so n times n is n squared, and so on and so forth. So just for a small thing, what we would do is n minus 0,08 times n minus 0,08. So n times n squared minus 0,08n minus 0,08n plus, and so this is plus 0,16, no, 15, 0,8 times 8 is 56. 8 minus that is n squared minus 0,16n plus 0,56. And then you multiply this in. So this will be in a bracket. Then you multiply this in, and so on and so forth. You do the same with each one, but not all of them are n squareds. But this basically breaks down to foiling, and when you foiled everything out, it comes out to this quadratic equation. When you finished foiling everything, it will come out to this quadratic equation that we are seeing here. So, what we do to solve this is, because there is no clear-cut way to factorize this. There's no hard and fast clear factorize. So you can do it one of two ways. You can either You can either use the quadratic formula, or you can complete the square to solve this. You can do either or, it doesn't matter. You will still get exactly the same answer. You will get two answers in fact, but the main answer that we are looking for is our positive answer, because you'll get a positive and a negative answer for this. Because the reason you can tell that is because this is positive and that's negative. If that's negative and that's positive, you will still get a negative and a positive answer. So you want the positive answer, and the positive answer for n is 0,0791 meters. That is n, and n will be very important when we are doing the next round of sums. N is very, very important for the next round. We are looking for the maximum bending moment that the beam can handle. So what we need to do first is take IA equals D minus N over 3. So this equals, so IA will be very important later. LA will be very important later. So that's 0,6, that's our D, minus N, which is 0,0791 over 3. And IA gives us 0,574 meters. So IA is 0,574 meters. Okay, the next thing to do is we want M. We want a bending moment. We want a moment. So in this case it is 0,5 stress of concrete times area of concrete times LA. So what we want now, 0,5 times the stress in the concrete is 5,2 megapascals. 5,2 times 10 to the 6. Now the area of the concrete times 0,5 times. Now we need to take N, which is 0,0791 multiplied by IA, which is 0,574, which equals, put this all in your calculator, and once we've put it in our calculator we get 58,964 kilonewton meters. So M equals 58,964 kilonewton meters. Now, what we need to do, this is M, that's a moment for concrete. Now we need to get an M for steel. I need to get an M for steel. So it is stress of steel times area of steel times LA, which equals 140 times 10 to the 6 times 200 times 10 to the minus 6, because this is 0,574 equals 16,062 kilonewton meters. So in this case, what we want is the moment of the steel. We've done two things here. They want the maximum bending moment. They want the maximum bending moment that the beam can handle. Well, what the beam can handle, therefore, what the beam can handle, the bending moment the beam can handle, is 16,062 kilonewton meters. That is what the beam can handle. So, MS for future reference. Right. Now we're going to do 6,3. Question 6,3. We are going to say the stress, the actual stress in the concrete. So, M equals 0,5 stress on the concrete, area of the concrete, and LA. Well, we have M for concrete, which is 16,062 equals 0,5 stress of the concrete, area of the concrete, and the area of the concrete is times 0,5 times 0,791 times LA, which is 0,574. All we have to do here is manipulate formula, and then we get the stress. And this is times 10 to the 3. All we have to do is take all of these and divide them by this, and we get our stress. So our stress for our concrete, is 1,417 megapascals. The stress in the concrete is 1,417 megapascals. Right. So 6,4 now. They want the moment, the actual moment of resistance of the concrete. Quite simple to do. MC, moment of resistance, 0,5 times stress of the concrete times area of the concrete times 2/3 N. So N has become valuable again. So equals 0,5 times the stress of the concrete, which is times 1,417 times 10 to the 6 times the area of the concrete, 0,5 times 0,0791 times 2 over 3 times 0,0791. And all this equals to MC equals to 1,477 kilonewton meters. MC equals 1,477 kilonewton meters. That was 6,4. Now we're doing the last question, which is 6,5. So 6,5. Now we are left with MS. So the final question is the actual moment of resistance of the steel. So MS equals stress of the steel times area of reinforcement times D minus N. Okay, so MS equals 140 times 10 to the 6 times area of the steel, which is 200 times 10 to the minus 6 times 0,6 minus N, which is 0,0791. And MS for the steel is 14,586 kilonewton meters. If you found this tutorial helpful, please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.